do you want to start?
At 78.
Okay. All right. One at a time. Let's graph this first one. How are we going to graph it? To graph all of these inequalities, if they're linear, this one's linear, then put it into y equal mx plus b format. That's your beginning spot.
Okay.
So solve that inequality for y.
Minus 6y. And then, equals to...
Well, for the moment, we're going to maintain that.
Okay.
Not really equals, but we're going to solve it as if it were equals.
Yeah. So less than or equal to minus 3x plus 12?
Uh-huh.
Okay.
Sign in front of the 12 didn't change. Okay, now what's the next step?
You have to divide it by 6.
By negative 6.
Okay.
You got to isolate that y. There is both a negative and a 6 in front of it. Okay, I got to divide that by negative 6. I got to divide that by negative 6. And the fact that I'm dividing by a negative number does what to that sign?
It switches it.
Okay, so what's my answer?
So y is greater than or equal to, would that be positive 2x?
Not 2. What's 3 divided by 6? 1/2.
Oh, one half.
And then this becomes what?
Negative 2?
Okay. Now we can graph that as if it were an equation. We're going to use a dotted line or a solid line?
This one we use solid, right?
Okay. Where do we begin?
At negative 2.
Okay. What do we do next?
We go up 1 over 2 to the right.
Okay. And then we connect those points with a straight, solid line, straight as I can get it. Now, which side of that do we shade? Because this is an inequality. It is not an equation. What we have shown there is the equation of a line. But an inequality means only one side of that line do we shade. Is it top or bottom?
Top.
Yeah, and always refer to it as top or bottom, not left or right, no matter what the line looks like. It's top or bottom. Okay, now the second one is a quadratic, not linear. Where's the vertex? It's in perfect vertex format. Where's the vertex?
Minus 1 and positive 3.
Does that say x minus 1?
Yeah.
Then it's at positive 1.
Okay.
Positive 3. In other words, here's the general format. These general formats is what you have to memorize.
Yeah.
You don't have these memorized, you're going to have a hard time with these. That's the general format. So what does that make h and k in our problem?
+1 and then 3.
Correct. So the vertex is right there. Does it open up or down?
It opens down.
Because of that negative sign right there.
Yeah.
Okay. Now, before I draw it, I really need a second point. Or 2 more points, actually. In other words, I cannot draw a parabola based on 1 point, even if it's the most important point, the vertex. Where does this thing cross the y-axis? Which is usually the easier intercept to figure out.
It crosses.
What do you do? What do you substitute into this equation in order to figure out the y-intercept?
0.
For?
X.
Okay, do it.
Well, you'd get, so, over,
Substitute 0 in for x and solve the right side of that equation or of that inequality.
so you get 4.
No,
Or
not.
-2.
You get +2. All right, here's what you get. Minus 0 minus 1 squared plus 3. Now work from the inside out. What is minus 1 squared?
+1.
Okay, and now you have a minus +1 plus 3.
Okay.
That's equal to 2. So my y-intercept is right there. And what else does that now allow me to draw as my third point?
Across from it, which is 2, 2.
Perfect. So now I can draw a parabola facing down. And not sure that we have to have the x-intercepts. Well, hold on a second. I did do one thing wrong.
It's dotted, right?
Dotted, exactly. And which side of that do I shade? Of the parabola.
You shade down.
Correct, because it's less than. In other words, you always use your y-axis to determine which side you shade. And what that gives me is a region. The common region is that region right there. So that's the solution. Okay, it's not down here. That's not a solution to both. And it's not up here. That's not a solution to both. The only area of the graph that solves both of those is the area that I've shaded in blue. Okay?
Okay.
All right. Next one is the same thing. It's a linear equation and a parabola, a quadratic.
All right. So
Graph,
can't we?
graph the
We
first
can.
one.
Okay.
Pretty easy.
So you start at -2.
Okay.
And you go up 2/3.
Which way over?
Left.
Notice that that gives you a negative slope, which is what you want. You know that it's -2/3. That is a negative slope. Now, is it dotted or solid?
It's dotted.
Okay. Which side of that?
And then below.
Okay, good. Now let's graph the other one. Where's the vertex? That's a quadratic. That's a parabola.
-2 and +3.
-2 and -3.
Okay.
Remember, what's the vertex format?
Y = ax minus h squared plus k.
Plus k. If it's plus k, that makes the y-coordinate -3. You're correct on the x-coordinate. -2 -3. -2 -3. Does this open up or down?
It opens up.
Why? I got it wrong. It's -2 plus 3. Excuse me. No, it isn't. It's -2 -3. Okay, and they're going to give us a strange problem here. Is it open? I know why you set up, but you weren't looking at that. Look at that and tell me which way it opens.
Oh, it opens down.
Now, my apologies. It does open up. In other words, it's got, I'm sorry, I didn't mean to be tricking you. I was confused. It's got a plus in front, right?
Yeah.
That means it opens up.
Okay.
Okay. Where is the Y-intercept? Just plug in zero. Plug in 0 for X. That's all you have to do.
Is 1.
Okay. And what's the other symmetrical point also?
It would be 2 and -3.
Here is the line of symmetry that goes through this parabola. So the other symmetrical point has to be right there. What are the coordinates on that point?
Oh. Okay. So it'd be -4 and +1.
Good. Is it a dotted line or a solid line?
It's dotted.
Okay. And do I shade above or below?
Below.
Okay. Means we're shading down here. Right?
Yeah.
Now notice that the common region is not the area that's encircled by those two. In other words, yeah, sorry, you can't see, but it's not that area there. The common region is wherever we have both pink and blue, which is only there. That's the common region, and it's infinite. It's not finite. All the other problems we've ever done like this have been finite.
Okay.
But not this one. Still the common region. It's just not the area you expect it to be. All right, let's do a little trig. Of sines and cosines. Well, let's draw a triangle first of all to see which one we're going to use. And we have a triangle that's ABC. Label that for me. Much as you can.
So A is B is 79 degrees, the angle, and then it has a length of 32, and then C is 45 degrees.
Which means A is what? In other words, they've given you angle, angle, side, but the key thing is they've given you an angle and its opposite side. That means we're going to be able to use the law of sines.
Yeah.
Whenever they give you an angle and its opposite side, you're going to be able to use the law of sines. However, we can figure out angle A pretty easily. What's angle A? Using your
56 degrees.
Okay. Now, using the law of sines, solve for side A only.
So you can do 32 over sine 79 degrees. Sine 79 is equal to A over the sine of 56.
Yeah. Notice that that was a clever way to do it because you left what we're trying to solve for in the numerator, which means we don't have to cross multiply and then divide. We can just multiply both sides by sine of 56. So the answer has to be 32 times the sine of 56 all divided by the sine of 79. That is side A, which is the only thing they ask for. You have your calculator?
Yeah.
Go ahead and come up with that, just so I can show you that we're going to do a ballpark check here. Make sure we haven't, the advantage of the ballpark check with trig is if your calculator's in radians and you think it's degrees, it'll point it out to you. The ballpark check won't make any sense. And so it's kind of a good way to flag making that mistake. What do you get for A?
31.15.
I would have expected quite a bit smaller answer than that. Hold on, let me take my calculator. You see why? Whereas the longest side's always opposite the biggest angle. And the next biggest side is always opposite the next biggest angle, which is true, but barely. So let me do it. 32 times the sine of 56 divided by the sine of 79. And I get 26.85. Makes more sense to me. I want you to do it again. Let's figure out where you're going wrong. The last thing in the world you want to do is miss these because you don't know how to do it on your calculator. What calculator do you have?
TI-84. Oh, I see what I did.
Change it, redo it, make sure you get that answer, 26.85. Now you got to make sure you're in degrees. Make sure you're not in radians.
What'd you say you got?
26.85. Which makes a lot more sense than 31.15.
I got 27.
Okay, well, it's a round off error. But let's look at why that makes more sense. What is wrong with the answer 31.15? It's too close to 32.
Yeah.
And yet these angles are not that close. That's 79 degrees, that's 56 degrees. There should be a bigger difference in their opposite sides. And 31.15 was just barely smaller than 32. It didn't pass the smell test. So I did it again. That's a far more believable answer. All right. '81. Draw a triangle. Doesn't even have to be the scale. Label everything you can on that.
Length of A is 18, length of B is 26, and length of C is 24.
Okay. Those are called little a, little b, little c. As opposed to capital A, which is generally an angle, capital B, which is an angle, capital C, which is an angle. Now, do we have a relationship between an angle and an opposite side?
No.
So what do we have to use here?
A squared plus B squared, A squared equals B squared plus C squared minus 2. So we have to use the law of cosines.
Okay, that's what I was looking for. The law of cosines. And it's A squared equals B squared plus C squared minus 2 what?
Times BC multiplied by cosine of A.
Yeah, it's the law of cosines. So you know there's a cosine in there somewhere. Okay, so fill in everything you know. Don't do the calculations, just fill in the numbers and we'll then do the calculations.
So 18 squared is equal to 26 squared plus 24 squared minus 2 times 26 times 24, and then cosine A.
And notice the only variable there is that. Everything else is a number. So you can solve for the cosine of A, and then you can take the inverse cosine of that number to solve for A. So let's do that. I don't know the best way you have of doing a problem like this. If it were me, I would do each of these individually, write it down as a third line, and then go from there. In other words, what's 18 squared?
324.
It's 26 squared.
676.
24 squared.
576.
2 times 26 times 24.
1,248.
Cosine of A. Now, next step.
Do you combine b squared and c squared?
Okay, what's that combined to? 1252, I believe.
Yeah.
Okay, now what?
Do you divide both sides by 1252?
You always get rid of stuff that's being added or subtracted first. You don't do the division until that's the last step. So I subtract 1252 from both sides.
Okay.
What do you get on the left?
Negative 928.
Okay, and that's equal to this. Now what?
Now you divide?
Yeah, because the only thing left is that, which is currently a multiplier. So we're always going to do the opposite. But you got to get rid of the stuff that's being added or subtracted first. These multiplying and dividing is the last step, is always the last step. Almost. So divide both sides by this minus 1248 and tell me what cosine of A is equal to.
One second. .7435.
Now tell me what A is equal to, because that's what they're asking for. Is angle A.
So do you do cosine 0.7435?
Inverse cosine of that. In other words, to find angles, you always use inverse trig functions. To find ratios, you always use trig functions. So you take trig functions of angles to get ratios. But if you have a ratio, which is what we have there, that is a ratio, a number, and we're looking for angle A, then we have to take the inverse cosine of that number. What do you get?
41.96.
That's angle A. Now, what's the next step? Oh, actually, that's all, because that's all they asked for was angle A. But what if they'd have said solve the triangle? What would the next step be?
So now you can do law of sines.
Always. Whenever you use the law of cosines as your first step, it always gives you that relationship between an angle and its opposite side, and you can solve the next angle using the law of sines. Then there's only a third angle to solve for, and you can solve it by just subtracting the other two from 180. So whenever you have a triangle that's side, 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 it's basically 3 steps. You use the law of cosines to solve for one angle. Then you use the law of sines to solve for a second angle. And then you use just the fact that the sum of the angles is 180 to solve for the third angle. But when they say solve a triangle, they mean solve for all 3 angles, all 3 sides. It's always what it means. Now, they have not asked for that in either of these problems, because all they asked for was in the first problem, find side A. They didn't ask you to solve the triangle. And in this one, find angle A. They didn't ask you to solve the triangle. But beware, they might. Now, I don't have a lot of time left. I'm reluctant to spend it all on law of sines and cosines. You appear to know it.
Okay.
I'm more concerned about these sequences down here. Let's go down and look at some of these sequences, and then if we have time, we'll go back and do those 2 trig problems we didn't do.
Okay, yeah. And then after that, there's one other thing which I want to look at, if we can look over.
Okay. Let's do these sequence problems and see if we can figure it out. First of all, what you have to know whether they're an arithmetic or a geometric.
Yep.
So for arithmetic sequences, what's the general formula for the nth term?
Plus?
Again, these are things you have to memorize. I cannot help you with them if you don't memorize them. There's not going to be a cheat sheet where it's going to give you all these general formulas. The secret to math is to memorize the general formulas and then just plug in. Okay, the general formula for an arithmetic formula is the first term plus the common difference times n minus 1. That's the general formula. Now, let's talk about geometric sequence, because it's different. Nth term is equal, they both start with that, only this is times a common ratio raised to the nth minus 1 power. So these two are quite different. One has a common difference, the other has a common ratio, which tells you a lot about the difference between arithmetic and geometric sequences. 84 is what?
So it's geometric.
85 is what?
It is geometric.
86 is what?
Arithmetic.
87 is what?
Arithmetic.
Okay. So the top 2 are geometric, the bottom 2 are arithmetic. So let's start with the geometric formula for this one. A sub n, when they say the explicit rule, this is what they're talking about. As opposed to there's another term they use, recursive rule. There's a recursive rule also, but we won't worry about it if they don't ask us for it. So what can you fill in here? Oops, hold on. I wrote the wrong one. I wrote the arithmetic. They usually start with they usually start with arithmetic. This one started with geometric. That n minus 1 is an exponent. So, what is the nth term equal to?
0. 1.
What's the first term? That's
2.
what that means. A sub 1 means the first term. What's the common ratio? What is every term multiplying the previous term by?
2.
There's your answer. Notice, check the fourth term. Is it 16?
Yeah.
Yeah. A sub 4 equals 2 times 2 to the third power, which is 2 times 8, that's 16. So it's always a good idea when you're dealing with sequences that once you come up with what you think the answer is, then check one of these terms. In other words, the third term needs to be 8. The fifth term would need to be 32, and so forth and so on. Okay, so let's do 35 real quick. These are pretty easy for the geometric. That's why they gave them to you first, because there's no simplification to be done. Whatever you get with that first shot is usually your answer. So what's a sub n over here?
64 times 1/4. And then n minus 1.
Yeah, and there's no simplifying that. Just in case you're wondering, there isn't. So that's your answer. That's why they gave you geometric before arithmetic. I'll show you why. Because arithmetic are actually harder. Because you have to do an algebraic step. So give me the arithmetic for 86.
So a of n is equal to 1 plus
What's the common difference? What's the common difference?
plus 3
times n minus 1.
Yeah.
Now, the reason this is harder is because I can simplify that. In other words, if I distribute my 3, I get 1 plus 3n minus 3, which turns into 3n minus 2. And that's your answer. So there's always those two additional steps when you're doing arithmetic. Notice we didn't have those when we were doing geometric. The first thing we wrote was our answer because the variable was in the exponent. Well, when the variable's not in the exponent, you can generally simplify it. So how about 87?
So minus 6.
What's the first term?
Oh, 6. Sorry, I couldn't see. 6 minus 4.
Hold on. Okay, I'll go with that. It's plus a minus 4. Okay.
N minus 1.
Simplify it. One step at a time.
So do you...
Distribute the minus 4 to both terms inside the parentheses.
So for n, you substitute it for n?
Got to simplify that. Not substituting anything. Step 1, it's the explicit rule. When it asks for the explicit rule, the left side of the equation is a sub n. If it asks for the recursive rule, the left side of the equation is a sub n. So whenever it asks for a rule to govern one of these sequences, it's asking for a sub n. Now simplify that part.
Is it positive 4?
First of all, distribute that term to both the n and the minus 1. That's how you simplify an algebraic expression.
So
what's minus 4 times n?
minus 4n
What's minus 4 times minus 1?
plus 4.
Now simplify that.
6 minus n?
This is what you're combining, the two numbers.
Oh, okay, 10 minus 4n.
Again, we had to do two additional steps. Once we wrote the explicit rule, you can, with an arithmetic sequence, you're always going to be able to simplify that explicit rule into a simpler expression. Whereas the geometric sequence, that rarely happens. Usually the geometric sequence, whatever you substitute on the first go around is your answer. Okay, you said you had one other problem you wanted to ask about. What is it? You got enough time for another problem? Is it one you can verbalize?
Yeah.
Then let me pull up my writing tablet. Okay.
We're just solving an inequality and putting it on a number line.
Okay. What is
so 7x plus 13 is greater than or equal to 4x minus 11.
Okay. First of all, solve it.
So is this where you set one side to 0?
Nope. That's quadratics.
No.
That's quadratics. When you're dealing with linears, this is either a linear equation or a linear equality. It's a linear inequality. But you gather all your variables on one side, all your numbers on the other.
So minus
which side, first of all, do you want to put your variables on? The left or the right?
The left.
Okay, what does that give you?
So add 11.
No, your variables are going on the left.
Yeah.
Your numbers are going on the right.
Minus 13 and subtract 4x.
Okay, tell me what the next line is.
3x is greater than or equal to minus 24.
And the next line.
Do you divide it by 3? Yeah. So x is greater than or equal to minus 6.
Or 8.
Or 8.
Graph that. That's what they mean when they say graph it on a number line. You're not graphing it on an XY plane. You're graphing it on an X number line. How do I graph that? What's that mean? Okay, here's what it means. It's a solid dot because it's greater than or equal. If it was just greater than, it would be an open dot. And then I have to indicate the direction. Well, the direction is that way. X is greater than negative 8. So that's the answer right there in terms of graphing it. Okay?
Okay.
And if it was less than or equal to negative 8, then it would be that way.
Okay.
If it was just greater than negative 8, it would look like an open dot, like that. So the difference between a closed dot and an open dot is whether it's greater than or equal or just greater than. And in this case, the problem they gave us was x is greater than negative 8. So if I wanted to write that in interval notation, it would be minus, hold on a second. First of all, it'd be a bracket because it can be negative 8. and then it would go all the way to infinity. So that would be the interval notation answer. That would be the graphical answer, and that would be just the answer to the inequality. All of them are the same thing. All of them mean the same thing. Got another one like that? You still seem a little puzzled.
Yeah, I have another one.
Okay, what is
So it's in absolute value.
Okay.
So absolute value 3x plus 5 is less than 13.
All right. What you have to know on these is this means two things. As long as you can figure out what two things this means, then you'll be able to solve each inequality that results. So what's the first thing this means? The first thing is always whatever it says minus the absolute value sign. So just rewrite what you're looking at, take away the absolute value sign.
Yeah.
That's the first thing it means. What's the second thing it means?
3x plus 5 is less than minus 13.
In inequalities, the second thing you have to change both the direction of the sign and the number. So it becomes greater than minus 13. In other words, this part here requires two actions. I got to switch the inequality sign and I have to change the sign on the number. If this was an equation, the only thing you would have to do is change the sign on the number. So an inequality is slightly harder because you have to do two things over here. The first thing is the same whether it's an equation or an inequality. You just rewrite the thing minus the absolute value sign. Now, solve the first one.
So minus 5 on both sides, and that gets you 3x is less than 8, and then divide by 3, and you get x is less than 8 over 3.
Solve the second one.
Minus 5 on both sides, and you get 3x is greater than minus 18, and then divide both sides by 3, and you get x is greater than negative 6, yeah.
Now, what are the two important parts on my number line?
Minus 6 and 8 over 3.
Where does my answer go in terms of a graphical representation? It's got to be less than 8/3. It's got to be greater than minus 6. Where's that put it on the number line?
In the middle of both?
Okay. Open dot or closed dot?
Open.
At both ends. Open there, open there. The answer is every point in between. Notice that every point in between satisfies both that and that. And that's what you have to do, is satisfy both of them.
Okay.
Okay? As opposed to the previous answer, where we just had x is greater than negative 8, that goes all the way to infinity. So that had an infinite number of solutions. This one only has, well, this one has an infinite number of solutions also, but all of them are between minus 6 and 8/3. If I was writing this in interval notation, it would be parentheses and parentheses. Parentheses go with the open circles, brackets go with the closed circles. In other words, let's make this this. These are both closed dots and they're both brackets. Okay?
Okay.
Lachlan, good luck. You take your final tomorrow?
Yeah.
Good luck on it. Have a Merry Christmas and a Happy New Year, and I will talk to you next year.
All right. Thank you.
You're welcome. Bye-bye.